So as he mentioned, I've done a lot of different things and worked in a lot of different places. So one of the things that's true about my talks is sometimes I make some claims people think might be outrageous. And I checked and they said that you weren't allowed to bring in rotten tomatoes and eggs and stuff. So here, you can use these if you'd rather. Here, that's a good start. So, you know, if the time comes when you feel like that's just what you got to do, well, you know, you got to do what you got to do. And so the point of all of the things I do is to do something that's interesting enough so people say, I don't think you can do that, right? That's what sort of makes it interesting and worth doing. So I'll talk about a few things that people might have reactions to that way. I've gotten that reaction sometimes. We'll talk both about this new project around security best practices, and we'll also talk about the Assimilation project, which is what started this movement in this direction from my perspective. So as he mentioned, he went through this stuff here and worked different places and did things and so on. So I've had a number of people say they like this shirt. And so I have a number of them. I have them in different sizes. So I will reward the best question and the best tweet with a free T-shirt. So keep that in mind. Those of you who are, that means that way if you have your phone out, I know you're just ready to write that tweet. So I won't be able to tell that you're really just playing games. So that's all good. The main thing is if you do fall asleep in here, the main thing is don't snore, because if you do, you'll wake up your neighbor. And that's rude. So let's start a little about how this project started. I'm going to start out with the Assimilation project, go into what it does and why this matters from my perspective, and then talk about this new effort to do that. And you can see how all the pieces fit together. Let's start with the Assimilation project and what it is and what it does and how it started. So I was working on a supercomputer that it was really one computer with all custom ASICs, all, not a normal cluster at all. It had 2.25 million cores in it. And it started making me think about extreme scale. The high availability stuff typically are really big HA clusters, like 10 or 12 machines. So it's a different perspective to say I have 13,000 blades with 2.2 million cores in it. And that made me start thinking about it. And so I started thinking about extreme scale. And then the particular computer had unusual topology as well. It was a cube computer. And then I realized that I had some what I think are pretty cool ideas on how to do this, some pretty cool ideas on how to do this. And I figured out how to apply these same ideas to normal computer environments. And then I started thinking, I want to discover the topology to be topology aware like I was in the other case. And then I said, if I could discover even more things, maybe I could also discover what services you're offering and stuff like that. And now, instead of starting out like monitoring, which is how it started, really the monitoring is now the effect of the discovery. And the discovery is really, I think, the main thing. And that's what drives the security, is understanding all the things you've learned through the discovery. And we'll talk about that. And of course, taking actions based on discovery and that kind of thing. So the basic outline of the talk, though, is I'm going to give a sort of this Assimilation System Management Suite overview, talk about the technology involved, and then I'll talk about best practice analyses. I'll do a little toy practice demo. So it's really best practice demo. I'll explain a little more about it, and then I'll talk about the current status, and then talk about what you need to do. How many people think I came here just to hear myself talk? Well, okay, besides me. So I came here really to get you to engage. There are lots of ways to engage, and you can engage by using this. You can engage a lot of different ways, but the point is I want to get you involved, whether it's using it, contributing to it, spreading the word, lots of different ways to get involved. So a little about what's in the suite itself. So we have this, remember I said it's all discovery based. So we create what's some people call a configuration management database, and some people hate that term because it has to do with ITIL and lots of overhead and everything else. But the point is, what if you had a database that was always correct and had everything in it and you didn't have to maintain it? Well, that would be a good thing regardless of what you call it. And I call it a CMDB so that the ITIL people will be happy, and everybody else, please don't be too offended by it. The DevOps people hate that idea. But the idea is it's always correct, it's always up to date, and it is created on the fly by discovery, not by human beings. So we also then monitor the things we've discovered, exception monitoring for those things. We'll talk about the security stuff at great length. And of course, we discover the network connectivity as well. You can discover all of these things in a way that, how many people think it would be good to have a security tool that set off security alarms? Well, okay, that's different. I mean, that's not what this tool is supposed to do. I'll put it that way. So we don't set off security alarms, and we do all this discovery and everything else. We do it, and we do it without causing issues on the network. So here's some trends, and statistics are, you know, lies, damn lies, and statistics, and that kind of thing. These are not my numbers. They're numbers from other people, from Verizon and James Turnbull and Jonathan Koomey. But you know, 30% of all break-ins come through systems people have lost track of. It's like, oh, I forgot we had that machine, or did we ever put that one in production? You know, they have this big effort to do something, and then the funding disappears, and everybody goes does something else, right? They transfer them all somewhere else. And the computers are still sitting there, not quite all set up. 90% of the servers that people have had failures of unmonitored services. That is to say, they have things they're not monitoring, and they failed, and oops, we had a problem as a result. 80%, this is the Verizon thing, on 80% of people who once get into compliance have trouble staying there. And a lot of people, it takes them 3 or 4 years to get in compliance anyway, which is kind of like eating the elephant. And if you're not staying in compliance, that's kind of like eating the elephant as an annual event, which doesn't sound too appetizing to me. So 30% of the people start monitoring only after a problem. The interesting thing about the Turnbull statistics is they're mainly what I would consider leading edge people. This is not the industry as a whole. The industry as a whole is no doubt much worse than this. The people he surveyed were mostly chef and puppet users, you know, who are mostly forward-thinking people by comparison to a lot of people in the industry. So these numbers, as bad as they are, the real world is probably worse than that. 30% of all systems are doing nothing useful. That is to say, you can get rid of them. I read an article recently about, I forgot which financial services firm it was, it's slipped my mind, but they got rid of 19,000 servers that they had out there doing nothing. 19,000 servers. So although people in here are no doubt a little farther ahead than that, this is the reality in the real world. This is why people get broken into it, have trouble managing it. Anybody think this is really looks good for us as a profession? No, I don't either. I think it kind of stinks. So these are the kind of things we try and address with the Assimilation project. Notice they're not all security related. And this is just me saying, how many people think they know all the dependencies of all their servers and how they all fit together? No, I don't either. I mean, I don't know. Maybe the people at Google or something where they drive everything out of a master plan of how everything works, maybe they do, but it's hard. It's hard to know how all the pieces fit together and how they depend upon each other. So these are the kind of things that are in our database that help you solve those problems. So a little more about why you want this. I mean, obviously you want to make those numbers go away, but so we're trying to help you provide insight and a lot of details on this through our CMDB is a graph database. So actually you can ask interesting questions like, tell me all the servers which depend upon this directly or indirectly. So in my experience, there are 3 kinds of documentation. The first and most common kind is the documentation you do not have. Then the second most common kind is documentation which is incorrect today. And the third and last kind of documentation is documentation which will be incorrect tomorrow. And so what we're trying to do is replace this kind of documentation as well, at least for those things that we can discover and through the system and understand ourselves, with a database that actually reflects what's going on and is kept up to date. Of course, we can also automate monitoring, enhance security, and create world peace. Oh, that isn't on here, is it? No, create world peace. Sorry, I just stepped out of where I'm on, the camera can see me. But we are designed for extreme scale. By that, I think of it, I know Google thinks the extreme scale is like 10 or 20 million computers. I think 100,000 is pretty extreme scale. For most people, that's pretty high. because remember, at the beginning, I started this by thinking about a system that had 2.2 million cores. And that's the sort of thinking that, in my mind, you know, I can't promise we'll deliver this, but in my mind, I always think, what if we had 1 million computers, would this work? Right? That's the kind of techniques we're using here. The kinds of things that at least hold up to the mind test of, yeah, you could probably make that work with this architecture. But I try not to promise what I can't deliver. So I didn't promise that, just be clear about that. Now the interesting thing here, how many people think complexity is one of the biggest problems you have in the data centers you deal with? The rest of you don't work with computers? Complexity is likely your single biggest problem, and I quoted myself as complexity is the enemy of reliability. You know, when I did HA stuff, I said that a lot. I said it a lot, and it's still true. Here are the ways in which two ways in which we reduce complexity, one way in which we help you manage it better. You know, if you don't have to configure stuff, that's less complex. You can't mess that up. I'm in favor of things you can't mess up, because otherwise I mess them up all the time. And seamless integration reduces the complexity too. Because of these pieces designed to work together from the beginning, they're all playing from the same sheet of music, right? All the different perspectives on this, out of the same database, out of the same understanding of the universe. That reduces complexity. Instead of having 4 tools, anybody had a set of tools that didn't play nice with each other? The rest of you only had 1 set of tools? And because we have an accurate and detailed view, that helps you manage the complexity which we can't have any effect over. You know, we can't change your architecture, but we can help you understand it better, and that will help you manage that complexity that you have better. So we have this. So anyway, this is basically a summary of what I've been saying here. We have a CMDB. We have the exception monitoring is extensible. The discovery is also very extensible, and it's really easy to extend. Anybody here ever think you could write a shell script that spits out JSON for the contents of a file or something like that, transforms it? Yeah, that's pretty straightforward. Most sysadmins can actually do that. And that's what it takes to discover something. And we put all of this in a graph database. The thing about a graph database, lots of interesting, cool things. A lot of the most interesting questions about a data center are fundamentally graph theoretic. Things like, what happens if I power this off? If I have a cascading failure, how do I figure out where the root cause was? Oh, I see I have one of these which doesn't depend on the other failed ones. That's maybe, as someone else said, patient 0. That might have triggered this. It's not necessarily the case, but it's the place to start looking when you start trying to understand what happened. And everything goes near this wonderful Graph Central database. So, you know, I'll wave the flag for Neo4j while I'm here. So how many people, this sounds unreasonable. Big scalability without a lot of complexity? Discovery without pings or port scans or setting off alarms? Anybody here think that sounds a little off? Good. You know, I like that, because sometimes I ask the question, how many people in the audience think I'm full of something? Yeah. Okay, now come on, raise your hands, guys. So there we go. So I like that, because that means you're paying attention and you haven't fallen asleep yet, which is a good thing. So, you know, paying attention is a good thing. And if you didn't think it was, when I do something that you think might be difficult or impossible, that's a good thing, because that means it's worth doing. So this is like, come on now, you're not you're really pulling my leg, aren't you, on this? So I'll talk a little bit about how this works in terms of scale. So I can explain how the scaling works so that your grandmother would understand, even if your grandmother isn't Grace Hopper. So this is really true. So at my church on Wednesday nights, we get together for a meal, and we stand around and hold hands like this. And while we're standing and holding hands in this circle, if Aunt Sally passes out, who notices first? Come on. The 2 neighbors next to her. Now, how many hands do you have to have to participate in this monitoring arrangement? 2. Very good. That's the right answer. The standard number is also a good answer. Some people try and answer some other question, but start with that. And so if I added 1,000 people to this arrangement, how many hands would you have to have? 2, very good. So did your work go up because I added 1,000 people into this human monitoring arrangement? No, you don't. Because if Aunt Sally passes out, are you going to tap the person on the shoulder and say, psst, 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 is there a doctor? Psst, psst, psst. Or are you going to pick up your phone and call 911? Okay? So what we've done is transform the monitoring into a 911 service. Now, that's why my t-shirt says Order 1. This part of the monitoring process is, in fact, Order 1. Everybody just has 2 hands. Anybody have trouble understanding that you only need 2 hands? I didn't think so. So I've actually had people who are non-technical explain it to other non-technical people because it's just so obviously true, right? So if you prefer the computer science-y kind of explanation, then see, this is my great pointer. See, isn't this a great pointer? So this guy sends A sends heartbeats to F and B, F sends heartbeats to A and E, and so on. So this is the computer science-y view of the same thing, but the other one's a lot easier to understand, right? People know how to hold hands in a circle. Everybody has at one time most likely done that. And this is how we currently work today. There are other cooler things we could do, and I would talk about if I had more time, but I don't. So let's move on. A little about the architecture. What we have is a central system, or a collection of central systems that are this collective management authority, which are written in Python, and they delegate everything out. The moral is, so another way of looking at what we do is we try and do as much nothing as possible. So and doing nothing really scales well. So if you've delegated everything out, then you have nothing to do but wait for the phone to ring. And hopefully your phone doesn't ring continually because of problems in your data center. It doesn't ring, every 10,000 times a second, which is what it would take to hit 10,000 machines with a ping each one, once a second. So you're down 3+ orders of magnitude in terms of complexity over what you were before, depending on the rate of change and the rate of problems that you have. So the nanoprobes are full. We farm out absolutely almost all the work we can, and trust them to do. All they really do on their own is discover their own stuff, listen to ARP and LLDP packets and CDP packets, and then send things back, and they'll send heartbeats when we tell them to. On their own, they do nothing except announce, hello, here I am, and announce, oh, I'm going away. And everything else is from the central system, so they have no configuration. Except maybe how to find the central. If multicast doesn't work for you, then you have to tell it where the central system is. If it does, you don't have to tell it anything. They're written in C, so they're small and lightweight. They invoke scripts, typical shell scripts for monitoring and for discovery. They send and receive heartbeats, listen for ARP and LLDP and CDP packets, and that's all they do. Anybody think this sounds wildly complicated? It's not. It's not wildly complicated. It's pretty simple. How many people are in favor of simple stuff? Yeah, my usual thing is simple stuff works. Complicated stuff works sometimes. And I usually go for the, works pretty well over the other stuff. Now, I can't really talk much about this, but I'll set that down because it's clumsy. But so, is it not? Here we go. So this is actually a sample of a graph that we build here. Here's a server, here's a NIC for it, here's some IP addresses, IP port combinations, an SSHD here and an SSH, which happens to be on the same machine SSHing back in. So in this process of discovering clients and servers, you put them in the graph together and, oh, you have dependencies, which is kind of cool. So I don't have time to talk much more about this because 40 minutes is short. We do a similar thing for NICs. We actually, and this is everything on all these slides, these 2 slides I was up here, it was discovered. Nothing was entered into my system by hand. So for example, this NIC on ETH0 here has a wired to relationship with this NIC called G3, switch port 3, which was labeled in the switches saying kitchen, north wall, white jack. Now I had to tell the switch that, but I did not have to tell my software that. The switch told it. So if you tell the switch the labeling right, so the label could be wrong, but the switch port 3, that can't be wrong unless the switch has a firmware bug. So this is the kind of stuff that all of this goes into the graph all automatically. So some questions about security here. Do you think good security staff is easily available? Do you think you can easily just pick up security staff, good staff, what you want?
There's a whole line of them out front trying to get hired, right?
Huh?
There's a whole line of them to get up right up front, right?
Exactly. There's a whole line out front. He said, obviously, big lines of security people. You know, the deal is there's a shortage of security staff, and it's getting worse, and it will continue to get worse. Anybody here think that security is going to get better anytime soon? No. If you do, you're in the wrong place, man. Do you think you have enough staff for security to keep up with changes at DevOps or Agile rates? So the moral of the story is, what this says to me is you can't keep throwing bodies at it and make it work. So in a lot of ways, security is behind the DevOps movement in terms of tooling. There's a lot more automation in the DevOps movement than there is in security. And a lot of the tooling that's there in security requires a lot of human intervention to get rid of the noise out of it, right? To filter out the noise. So at least for these tools, we want to provide more automation, move people more in the direction of automation, and so you can do more with the staff that you have, right? And hopefully do a little better job of keeping up. So this is the kind of stuff that some of these things we currently do in the assimilation projects, and some we're moving the direction of doing. So we already discover every IP address. Listen to ARP packets. If you listen to ARP packets on every subnet on most environments, you'll get all the IP addresses and MAC addresses of everything. We also monitor open ports and services. You know, doing a net stat on the machine periodically tells you kind of what's going on there. One of the collection of network-facing application checksums, we do that currently as well. Once we've discovered the set of things that's talking on the network, then all of a sudden, all we have to do after that is send another discovery request that says, go discover the checksums of these binaries. And since the class path is on the argument list of the Java programs, you know, the argument list is like this big, that argument list, except my arms don't stretch like a Java command line argument. In there is the class path. And so we also grab the class path and say discover those jars checksums, and it does an LDD to get the libraries as well. So we come back with all the checksums of everything. And by the way, it was automatically discovered. You didn't have to tell me what to do. If you add something else, you start listing on a new port, hey, we'll start doing that. So these last things here are things that we're not yet doing. I've had somebody say, wouldn't it be nice when I have a MAC address I've never seen before show up to do an nmon minus O on it to kind of characterize what it is? We only need to do it when, because we have a database and we remember it permanently, you only need to do it when it first shows up, at least for most things. And then also checksum outlier analysis. We have the checksums, and maybe you'd be concerned if you knew that 99 of your copies of your library were the same and the 100th one was different. Anybody think that would be an anomaly of some kind, maybe you ought to flag? But we have all the data to do that with, and we keep it up to date all the time without configuration on your part at all. And the security best practice analysis is what I'm going to talk about for the rest of the talk. So this is our next major plan capability notice the word planned. Life happens, and sometimes the best laid plans of mice and men don't work out that way. So this is what we're planning next, just triggered by discovery updates. So remember, this whole system works in a way such that they sit quiet until they have something interesting to say. So if something changes in your PAM configuration, you'll send a message saying, hey, here's my new PAM configuration. Something changes in procsys. There's 20 or 30 different procsys variables that are security related. It sends the new procsys. So whenever that changes, the idea is to say, I'll just run the set of checks which apply to that particular chunk of data so that you evaluate them if and only if they change. You don't evaluate them quarterly, you don't evaluate them weekly, you don't evaluate them annually, you evaluate them every single time they ought to be evaluated and no other times. So no changes, no analysis. And we can analyze anything we discover, it's a question of, and discovering stuff is easy. You write the shell script that takes whatever you want to do and spits it out in whatever format, in JSON, right? And our expectation is we will create alerts and reports on these as well. So here's the kind of things we want to look at as best practices. Inappropriate OS settings, basically hardening type stuff. One of the things we want to do as well, we already know all the packages, we already collect all the packages and version numbers of everything on your systems anyway. We have that data. So we want to also create a service which listens to all the various vendors, feeds, and then provides you a single consolidated feed in JSON of all of this stuff. So that's one of the things we want to do here as well. Inappropriate services. I actually visited a customer that was running Telnet, and they were telnetting as root. And when I talked to them, I talked to them and I said, you can't do this. They said, oh, we have a firewall. And I said, but you have 200 branch banks behind your firewall. I can't comprehend this. And I had to sit down and explain to him how one does social engineering to get behind that firewall. And it would take no more than 15, it would take a half day at most if you got really unlucky, right? Because with 200 branch banks all over, in this case, Vietnam, it's like you come in and you say, oh, by the way, I understand your computers have been slow. Anybody ever have a computer that wasn't slow? And so on. You know the drill. So it's like, people actually do this. So it really happens. Inappropriate application settings and hardening in that respect as well. So part of this process, there are two pieces of this. One is I want to write the code to do all of this. The second I want to do is create, and this is actually not just for me, but for the greater good, a place where we can collect these best practices in one place and get the participation who know more about this than I do. I know plenty enough to be dangerous, and actually I'm not as dangerous as I might be, but I don't know nearly enough to get all of these myself. Right? I know some places to get them, NIST with their STIGs and some other places. But we've created this itbestpractices.info site and a GitHub project to go with it, where the intent is to collect these in one place so that anyone they'd be available to anyone whether you care about the Assimilation project or not. Initial source would be NIST STIGs, the Linus project, and individual contributions, right? And notice it just says IT best practices. It doesn't say security. My personal emphasis is on security because I think that's the right emphasis for lots of reasons. One of which is I think I can sell my assimilation software more if I check security best practices and other things. But there are others as well. For example, I know some people here know about buffer bloat. Well, I have a check in here. I have it in there. I have one on buffer bloat because the Linux settings are almost wrong for almost every case. So we want to create this, and I'll talk a little more about what this looks like and what it doesn't look like, which may not meet your expectations. But I'll explain why, and I think you'll see why it makes sense. So we want to make these best practice rules available in JSON. We want to curate potentially verifiable best practices. A best practice that says interview the system administrator and ask them blah, 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 and look at this and this and this that you can't mechanically verify. I'm not interested in those because somebody else can deal with those. I mean, it's nice to have those, but I'm really concerned about the ones that I can actually help you with automatically because, as I said, it's the automation that's my immediate concern. So part of this is, interesting thing is it might take one line of code to say, is this value equal to 0, right? But it takes paragraphs and paragraphs of data to explain what it is, why you care that it's the 0, what the consequences of it being 1 are, and how you fix it if you want to fix it. That's actually a lot more work than the check to see what the value is. So the hard part is actually that, not the checks. I mean, it's good to have the checks, and that's a good place to have them. But every different tool has a different way of thinking about the universe, a way of getting its code out there, a way of analyzing its data. In our case, we look at JSON. In other cases, they'll probably grep the file, right? Everybody will have a different way of implementing it, but we'll all have in common the same description of the problem, the same description of how to solve it, the explanation of what it is and the impact of it so you can understand it, and that kind of stuff. So that's the part that would be common to everyone, and that's what I want to concentrate on in this project, because that's common to everyone. Not, as I said, not limited to multiple best practices, freely available, multiple language support. For example, in this STIGs, they have a lot of good stuff in them, but they're only in English. And they have no provision in the XML for multiple languages. I mean, they could, but they don't. And I don't particularly want to go back to them and argue with them they need to have multiple languages. Being the US government, they're not likely to care about that. But I think it's a good thing to do. Eventually, have these available through a web server so you could issue a query and get back the data so your application could go to the web server and for free get this data and display it to your customer whatever way you wanted to. The source text might change to YAML for readability, but I want to deliver the content in JSON because that's the, you know, if Perl is the duct tape of the internet, then JSON is the lingua franca of the internet. XML, it's not my favorite. So here's an example of a short description from a NIST STIG. The system must limit the ability of processes to have simultaneous read and execute access to memory. I don't think that's the best description of it, but it's their description and it's already written. So, and here's the long description. The status of the kernel exec shield kernel parameter can be queried by running the following command, blah, blah, blah. The output of the command should indicate a value of 1, so on and so on. This is actually taken from the NIST STIG, right? And so on. And this is a lot of stuff, right? And here it goes on to, here's the long description. Uses a segmentation feature, explains what it is, blah, 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 blah. And here's the rule to actually check it. This is what it would take to make my code actually validate this. So the rule kernel.exec shield has to equal 1. And the rule name is NIST v38597. So this is easy, right? Anybody think that this, and the other stuff is actually a bigger pain in the neck. And it's the kind of thing that's subject to more tweaking. So this is not what I want to put in the database because this is specific to me, right? You might do it a different way. I mean, you know, the $kernel.exec shield, that's kind of my syntax for it. And I don't want to argue over syntax. I don't want everybody to, I don't want to spend my time on doing that. I mean, I want to do it, you know, I don't think that's the best way to spend our time. I think it's better to get the rules together and get the text together and let everybody implement it themselves, especially when it's as easy as one line of code. I mean, it would be one line of code, except that, you know, you have to make it big and have it show on the screen. So, oh yeah, I missed one. So this is what buffer bloat prevention looks like. Kernel.core.default.qdiscipline has to be in, you know, this is like an in state. It has to be in the range of fqcodel and codel. It has to be in that list. So that's an example of one that's not security. So the project is free to do any of these things. I am personally going to spend my time. I'll pick these up like this because this is an obvious thing, and it's a good counterexample to how everything has to be security. And I'm happy to have those come in here. And people who are interested in the other areas are happy. You know, I'm delighted to have them come along. I'm just not going to spend a lot of my time on that personally. I'll do some. Somebody suggests it, we'll put them up, but I'm not going to go hunt them up. So I have a little demo, and it's a really toy demo, but you'll see the idea of it anyway, is of some test code in my source tree. The test data was discovered, it was out of the discovery, assimilation discovery from a real system, and this code was written for feasibility testing, so it does in fact implement exactly what you saw before, you know, the $ equals and all that, you know, the parenthetical kind of syntax. And all I have to do is remember how to do this. Alt-tab, right? Alt-tab. There we go. That should have switched. Now if I hit return on this, it'll come back so fast you'll think I just catted a file, but it actually runs some Python code. So, so I ran several tests here. It says this one passed. This is randomized VA space. It's supposed to be 2. These were not applicable. In other words, those variables are not in the version of Linux I was running, but I took the rules from Linus. These rules came from Linus, not from NIST. So some of these rules applied to versions of Linux that I don't have, so they're not applicable. Apparently I died here, which is okay. Oh no, it didn't. It's just a bad switch. So, of course, now it won't work at all over here. There we go. Hit it. That's the thing. So these were not applicable. This one failed. So this was, my machine is not set properly for buffer bloat, by the way, which is probably true for almost all your machines too. So in this case, it says go to this URL, and that will give you the explanation. This is before I created the other project, and so it's not it's not structured that way, but this is the idea anyway. And another one. Wasn't there another? There's another failure. So kernel sys request was not equal to 0. And you go there, and that will give you the description of that. So this is just, the idea of how this thing can work. They're very straightforward. They're very simple. I have about, the project currently has 270, 250, 275, somewhere in that range, NIST STIGs. They call them STIGs. I don't know why they call them STIGs. But yeah, unfortunately, I have to go. What I remember is that I have to actually escape out of this, do F5, and then go forward 35 pages. I tried. Okay, it's not doing anything. Okay, that didn't do it. Oh, I have to F5 again. Apparently, it won't do F5 anymore. Oh, that's good. It did it before. Okay. Let me start it up again. Close without saving. I didn't mean, if I made any changes I didn't intend to. Let's see if I can start it up again. Maybe I pushed F6 instead. I don't know. Anyway, I pushed F5 now, and now it's working. I just have to go forward about 35 pages. I counted it. Oh, no, it's not 35, apparently. Page up. Okay. Page down. Yeah. So the current status is, we put out a release, a 1.0 release. Release numbers are so weird. Finally decided to go 1.0 on July 4th. We have strongly encrypted communication. The security emphasis is our next major feature. Discovery and automatic monitoring. So discovery leads to automatic monitoring and network-facing checksums. We are added in that release compatibility with Nagios for remote execution. So if you have things that you've written to make Nagios monitoring work, those will work with us. We have REST and command line queries, great unit and system tests, and license done to the commercial or GPL. So the next stage is for you to get involved. We're looking for early adopters, people to try this out. We have a few trials underway. We're looking for contributors of all kinds. If you have anybody here have a skill, any skill? Apparently not. One person has skill. I'm glad. The rest of you don't have skills. But if you get skills, you can come contribute any skill. You can contribute to the project because we need probably whatever skill you have or whatever fun thing you like to do. Enjoy. If you're geeky enough to be here, you probably like computer stuff, right? So we probably need that on the project one way or another. All these kinds of things, right? So these are what. So no one has asked any questions yet. So. No one can win the T-shirt unless they ask questions. So I should have said you can ask them all along, but we'll ask. Hopefully I'll have a minute or two at the end here. I'm not sure what time it is or what I'm supposed to be done, but we're getting close to the end. These are the things we need. So so I have a BOF tonight at 7. So there's lots of stuff I had to skip over. There are like 20 more slides in this deck, which I moved to the end because I wouldn't have time to cover them. Tonight at 7 to 8 p.m. in room E145. And I will give away I'll have other swag to give away there as well. So, and just remember, resistance is futile. This is the Assimilation project. So there's hardly any joke that's a pun that's so bad that I won't make it. Just keep that in mind. You can get these slides here at Assim OSCON 15. The mailing list is bit.ly.asimml. We have an oops. That's a cool slide that I didn't have time to cover. We have an IRC channel, which I'm on most days. Sometimes, like if I do an OS upgrade, I'll forget to start it for a few days. And these various URLs and so on, and places to download it. Now, I don't know how much time I have left. Does anybody keep track of that? How much time do I have left? What? Right now I'm out. So the next one starts in 10 minutes. So I'll take 5 minutes of questions, and then I'll get out of here. What questions do we have here, people? Oh, come on. Somebody has to have a question. Oh, you do. I'm sorry. Go ahead.
What are the top 3 most common security mistakes making discovery?
So we're just starting this, and so I can't answer that question because we're really. I haven't written all. I've written some test code for this, but I've not deployed it anywhere, and because it's not deployable yet, it will be in the next release. Yes.
So the example that you showed, is that working off of a Neo4j database, or is that?
So I discovered it, put it in the Neo4j database, extracted it, and put it in my test code. Okay. So it was all the data was in the Neo4j, but the code didn't pull it out of the Neo4j database. It pulled it out of a copy because it's test code. The test code came from a real system, and the test code didn't have the real system, available to it. It had a test system.
It was automatically discovered.
Absolutely. It's not hard to imagine discovering proxys. It's very. There are like 3 or 4 things in there that turned out to be random, and you have to throw them away because otherwise, the thing you think it's changing all the time. There's like a random number or something in proxys. Yes.
How do you deal with the potential for network for split brain or for a flood to come back if each of the individual agents goes, my neighbor went away, and all ping home at the same time?
So.
You just lost yourself.
So. The moral of that story is that they send the packet and we ACK it, right? So if everything goes down at once, then they're going to come up. So let's talk about the mechanism for that. Maybe at the BOF, because there are lots of, depending on how it happened, the answer comes out differently. Yes, that's a good question though.
So how do you see your vulnerability or your best practice database interfacing with something like SCAP or other efforts?
Which other efforts? I'm sorry.
Well, like SCAP, right? The open, or the DoD is using another.
Yeah. So those start out as the NIST STIGs,
Right.
and so we're bringing them into here as a piece of what we provide. Okay. I already have 275 of them from Red Hat 6 in there now.
So you're going to assimilate those.
I'm going to assimilate those. Yes. I mean that in that sense, we're going to assimilate those because I don't want the XML. I want them in JSON, and I want to have the opportunity to correct them without having their administrative process involved. I mean, we can feed them back, but I don't want to have to get tangled up in that just to fix something.